This movie describes how to use the activity Color Calculator, Decimal Representations of Fractions. Here we have the fraction 1/4, and to its right we have its representation as a decimal. It's 25 hundredths. Notice that each digit has been assigned a unique color so that all zeros are red, the 2 is a shade of yellow, and 5 is blue. We also see lots of digits to the right of 5. They're all 0 in this case because 1/4 is a terminating decimal. It ends in 0. Let's try a different fraction. I'm going to change the 4 to a 3, and when I click outside the box, my decimal representation changes, and I see that 1/3 is composed of all 3's. It's 0.333333, and so on. This is a repeating decimal. And notice again that all 3's are green and my 0 is red. Let's try a more interesting fraction. How about instead of 1/3, we try 1/7? 1/7 is very colorful. It has lots of digits in its decimal expansion. To gain some more understanding about its expansion as a decimal, I can drag this red point that sits in the lower right-hand corner. As I do, my digits will stay the same, but the size of the array in which they sit will change. So if I drag one space to the right, I begin to see an interesting pattern. I see that all my 7's lie along a diagonal, as do my 5's, 8's, 2's, and 4's, and 1's. If I drag, I can continue to look for patterns. Here's an interesting one. I see that 1/7 is equal to 0.14285714285714, and so on. In other words, it's a repeating decimal. This sequence of 6 digits repeats over and over again, and seeing it in this form makes it particularly vivid. It would be hard to see this repetition if I was using a calculator instead, where I only saw a limited number of digits. Now this version of the color calculator shows both digits and color. Another page of the sketch shows just digits, and my favorite page is the just color page. So here we see 1/7 represented with just the colors but no digits. But it really tells us a lot of information even this way, because we can see by dragging that, again, we have a repeating decimal because the colors repeat, and it repeats every time we have 6 different colors. So the activity itself encourages students to try a variety of fractions, to look at those that terminate, those that repeat, and those that have interesting patterns, both in the digits and in the color. This activity was inspired by work from Natalie Sinclair.